Okay, let's assume that you have 3 electrons. You put them on vertical line in this case. You fix the first one and the last one in their places. And the second one is right between them at some distance, 1 millimeters, or I'm going to call it A, from both. Now, if this second electron is exactly between the 2 electrons, at this point, it would be a semi-stable or unstable, basically, condition for electron. And so if you disturb it a little, just let's say you move it to the right side by a little, then this electron is going to feel the repulsive force from these 2 electrons and is going to start moving, gains velocity, and eventually goes to infinity. Now the question is, how much would be the velocity of this electron if we just displace it just a little, let's say to the right side of this unstable point right in the middle between the 2 electrons? Okay, so at this position, right between the 2, the electron has some potential energy. The potential energy is depending on the distance between the 2 electrons. So there will be a potential energy due to this, let's say, call it electron 1. It would be K, the charge of the electron times the charge of the second electron, that's e to the power of 2, divided by the distance between them, A. That's the total amount of energy which is stored in this configuration between 1 and 2 in the settings. There's also energy stored between the second electron and the third electron, which is technically the same because we put them exactly at the same distance. This is the total amount of potential energy that the system has. Now, you can say there is no external force. So if there is no external force, the work done by the external force is 0, which you can conclude that the change in the potential energy and the change in the kinetic energy would be 0. Or if you like, you can say the initial potential energy plus kinetic energy initial would be the same as potential energy final plus kinetic energy final. Potential energy initial would be the sum of U1 and U2, and it's exactly the same. So you will have 2K E2 divided by A. So that would be the initial potential energy stored in the system. Kinetic energy is 0. I'm going to assume that the system starts from no velocity. Just hold it there. A little displacement, but I don't push it. When it gets to the infinity, the potential energy would be 0. And then there will be a kinetic energy equal to half m velocity final to the power of 2. We need to solve this one for velocity final. So I'm going to isolate it for the velocity final. So the velocity final to the power of 2 would be, bring 2 to the other side, becomes 4ke squared divided by m times a times m. So I need to calculate the velocity final, which is root square of 4e squared will give me 2e, and then root square of k divided by a times m. Remember, a is the separation between the 2 electrons. So between 1 and 2 is a, between 2 and 3 is also a. And so you will have the velocity, the final velocity calculated from this relationship. Now, if you know what is the constant k, which you know, 9 times 10 to the 9, mass of the electrons, if you know the separation between the 2, which is 1 millimeter, and you already know what is the charge of the electron, E, so you can calculate the final velocity for this system.